Hi everyone, welcome to my new video in my Mathematics Essentials series. This video will be on some useful trigonometric identities. Okay, I'll actually cover many trigonometric identities in this video series, but I just wanted to give you a few up front, and rather than prove them, okay, I will talk through a geometric interpretation of them, so that you can get a more graphical intuition as to why they're true. Okay. Now, the first one is that negative sine of theta is equal to sine of negative theta. Okay. I'm just going to write them all out. Sine of theta is equal to the sine of pi minus theta. Sine of theta is equal to negative sine of pi plus theta. Sine of theta is equal to negative sine of 2 pi minus theta. Okay. Now you can see that on the left hand side, these last three are equal to sine of theta. All right, so these three on the right hand side are all equal to each other as well. So maybe I could explain why those three are true in one go, but that diagram might get a bit messy, so we'll see how we go there. Okay, now there are some cosine trigonometric identities I'd like to give you as well, and maybe the cosine ones will have to wait until the next video so that it doesn't get too long. But the first one is that cosine of theta is equal to the cosine of negative theta. Okay. The next one is that negative cosine of theta is equal to the cosine of pi minus theta. Negative cosine of theta is equal to the cosine of pi plus theta. Okay, so from this you can see that these two on the right hand side are equal. And the last one is that cosine of theta is equal to the cosine of 2 pi minus theta. Okay, so you can see that cosine of negative theta and cosine of 2 pi minus theta are equal because they are both equal to the cosine of theta. And you can also see that the cosine of pi minus theta is equal to the cosine of pi plus theta because both of those are equal to the negative cosine of theta. Okay, so maybe these ones that involve cosine will have to wait until another video, but we'll see how we go for time. Now, I will indicate which one I am explaining geometrically by a red star, so this is the first one we are going to explain. Let's get to it. Okay, I want you to consider a unit circle, okay, superimposed onto a Cartesian plane. So I'll draw my Cartesian plane. And try to center it a bit better. Okay, well, this here is the x-axis, and this here is the y-axis. And if we take a point on the circumference of the unit circle and draw a line to it, so Let's say I draw a line from the origin to some point on the circumference of the unit circle. It's going to have some coordinates with x and y components. Okay, now recalling our unit circle definition for sine of theta, where theta is this angle here that we've defined between the line from the origin to that point on the circumference of the unit circle and the positive x-axis. Okay, we know that sine of theta is just going to be y. All right, so let's write that down. Sine of theta equals y. Now, if we multiply both sides by -1, we'll have negative sine of theta on the left and negative y on the right. Okay, we're talking about negative sine of theta. Okay, now let's consider what negative theta would be. Well, negative theta would just be the same angle as theta, but measured clockwise from the positive x-axis to some point on the circumference. So this here, this angle, would be negative theta. Okay? And now I want you to consider what the y value is. Notice that the y value of this point here, all right, would just be whatever value we get by starting at this point and moving in a horizontal direction until we hit the y-axis. So whatever that y value is, okay, that would be this y value here. All right. Now, since negative theta has the same size as theta, it's just measured clockwise from the positive x-axis, and it's a unit circle. So this line has a length of 1, okay, because the radius of a unit circle is 1, and this line has a length of 1, okay. What we see in, trying to rub this purple part out. I think my pen is having trouble. Okay. What we see in this quadrant, what we see in this quadrant is symmetrical to what we see in this quadrant. Okay? There we go, my eraser is working better now. Which means that if we were to track horizontally across from this point until we intercepted the y-axis, okay, this y value here would just be negative y. All right, so whatever that y value is, the coordinates here would just be positive x and negative y if we were imagining this y value to be fixed. So maybe I should have talked about a and b instead of x and y, but this is fine. All right. So you can see now that the sine of negative theta is also going to be equal to negative y. Okay? So that's this one. Actually, I'll just tick them off. That's this one done. All right, now let's consider this one. And we can work with the same diagram. Okay, so here's our angle theta. All right, and what we are trying to show is that the sine of theta is equal to the sine of pi minus theta. All right, well, what would be an angle of pi? That would be if we went all the way around to this point here. Okay, so if we started here and went like that, that angle there would be pi radians. Okay, now pi minus theta would just be going all the way around by pi radians and then going back in the other direction by however big theta is. So let's represent that graphically. Okay. Actually, no, it was more like this, wasn't it? Yeah. So we're going to draw a line from the origin to some point on the unit circle, such that if we measured an angle here, just between the x-axis and that line, this angle would be theta. But if we measured an angle from here all the way to that line, this angle here would be pi minus theta. Okay? So we can see that if we consider this point here, its y-coordinate is just going to be the same as the y-coordinate of this point. So from that, we can see that since sine of theta is just equal to y, that the sine of theta is equal to, well, actually, I'll write it this way. The sine of theta is equal to y, but also that the sine of pi minus theta is also equal to y. So these two must be equal to each other. Okay, because you can see that they have the same y value. Okay, so that is this one done. Now, let's consider this one. The sine of theta equal to negative sine of pi plus theta. Well, let's consider pi plus theta. Pi plus theta would be this angle here. Okay? If we drew a line from the origin to this point on the unit circle, okay, this angle here between these two lines, okay, the negative axis and the line that I just drew, would be theta big. That's how big it would be. So if we went all the way around to here, this would be pi radians, but then we would be adding on this angle theta to get to this point here. Okay, so what we can do is say that this angle, okay, that angle is pi plus theta. Okay, that's how big that angle is. All right, and I want you to consider what its y value would be. So if we tracked across horizontally, we would get to whatever that y value is there, and it would be some negative y value. Okay, it would have the same y value as that point there. So we know there that the sine of theta, I'm just going to give this point coordinates a and b. Or if this one has coordinates a and b, you can see that this one would have coordinates negative a and negative b. Probably should have talked in terms of a and b from the beginning, but that's okay. Okay, we can see that the sine of theta sine of theta is going to equal this here, because that's theta, okay, which is just b, all right? And if we multiply both sides by -1, we get the sine of theta. Sorry, don't worry about doing that. Now, if we consider the sine of pi plus theta, okay, we know that that's going to give us that, negative b. Okay, so that will be equal to negative b. But remember, this property, or this identity here, says that the sine of theta is equal to negative sine of pi plus theta. So if we multiply both sides by -1, we have to do that on the right hand side to keep the equation balanced. We will just get positive b. So we can see that these two are equal because they're both equal to b, and that's just what the identity says. So we can tick that one off. All right, now let's consider this one. The diagram is getting a bit messy, so maybe I will start a new diagram. Okay, so let's consider another unit circle and a Cartesian plane. And that's the x-axis, and that's the y-axis. Now, what was the identity? 2 pi minus theta. Yeah, sine of theta equal to 2 pi minus theta. So let's take our ruler, a line from the origin to some point. This time I'll say that the point has x coordinates a and b, right? And this defines an angle here, theta. Now, 2 pi minus theta, all right? That would just be the angle we would get if we went all the way around the unit circle, 2 pi radians, and then went backwards, okay, such that the line that we end up at, which defines this point here, okay, defines this angle negative theta, right? But to go all the way around and just stop at that line would be like going 2 pi minus theta radians around the unit circle. So I'm going to get rid of this and try and get rid of that dot there, almost. I'm worried that if I try to erase it, I will get rid of the unit circle, but hey, that dot was exactly where I wanted it. So this whole angle, which I'll indicate in blue, that whole angle is 2 pi minus theta. Now, let's consider what the y value of this point here is. If we were to track across horizontally, we would end up here. Okay, so wherever that purple line intersects the y-axis is what the y value would be of that point, and we denote that by b. Now, let's do the same thing here. Wherever we intercept the y-axis here, okay, since everything is symmetrical, but just flipped downwards, okay, so it's flipped about the x-axis, we know that the coordinates of this point would be a and negative b. Okay, the x coordinate is going to be a because you can see that these 2 points have the same x value. So their x component is going to be a, all right? But their y components will be opposites in terms of what their signs are. Sign as in positive or negative, not sign as in the trigonometric function. Okay, so the sine of theta is just equal to b, all right? But consider what the sine of 2 pi minus theta would be. Well, the sine of 2 pi minus theta, okay, is just going to be the sine of the angle that I've indicated in blue, right? And we know that that's going to equal negative b. But if we multiply both sides by -1, okay, we're just going to get positive b on the right-hand side, okay? So both of these are equal to b, so they must be equal to each other. And that is just what this identity says. So you can tick that one off. All right. Now, these I will do in the next video so that this video doesn't become super long. These are just some useful trigonometric identities that involve sine of theta. And I hope that I've been able to give you an intuitive geometric understanding as to why they are true. Okay, if you found this video helpful, give it a like. Feel free to share it with your friends. And if you want a notification when I upload a new one, subscribe to my channel. Until next time, bye for now.